Hey, honors chem classes. This is Mr. Lambert once again. It is just about 4 p.m. on Wednesday, March 18th. Wow, what a day. What a long day. I went through 100 emails answering questions from students, giving access to these screencasts. We're still trying to figure out the best way to do it, but I figured since I have an empty house, besides my dog, I might as well do a quick little video for you all on section 6.2. Before I do that, I do want to say, and make sure your parents know this, it is my pledge that you do not get out of Conval without having a top quality chemistry education. So this is why I'm doing these. I'll make them quick so I can chunk them into small pieces, 5 minutes, 6 minutes, or whatever, and get them up into Google Classroom. Section 6.2 is all about ionic compounds. I'm looking at the book here. I'm just making sure I hit every single point. Ionic compounds occur, they are compounds that occur between metals and nonmetals. So there's going to be a complete transfer of electrons. Quick little example that I believe is in the book. Yes, it is. If I take the element sodium, which has, there's the symbol for sodium. If I have one valence electron, because that's what sodium has, it's in group 1A. As we know, it wants to get rid of that one electron, that one valence electron, more than anything in the world. It's going to dump that electron onto an element that wants to gain an electron more than anything in the world. A great example of that is an element that has 7 valence electrons and is looking for that magic number of 8. We're going to call it chlorine. Here's Cl. It's going to have, as I said, 1, 2, 3, 4, 5, 6, 7 valence electrons. Please don't worry that I made this electron much bigger than I did these. Point is, sodium has 1 valence electron, chlorine has 7. This is looking to dump 1, this is looking to gain 1. So what's going to happen in an ionic bond? This electron is going to shift. It's going to actually get transferred. It's going to jump from sodium to chlorine, making sodium's inner shell stable with 8 valence electrons, even though it's not shown, and chlorine has its 8 valence electrons. But more importantly, sodium is, since it lost one electron, it lost one valence electron, and electrons are negatively charged, it is going to take a charge, an electric charge of +1. We just write that in chemistry as a plus symbol in the corner. Not 1 plus, not +1, just plus. Since chlorine took that electron from sodium, it takes a charge of -1, which we're going to write as a negative symbol up in the top right-hand corner. Since you know about the attraction between positive protons and negative electrons, these two elements get together and they will form the compound, they will form the compound NaCl. Notice that I don't write any charge up in the corner because the one positive charge from sodium has been balanced out or canceled out by the -1 charge of chlorine. So we write it with nothing up in the corners. The point is that ionic compounds should have an overall charge of 0. I'm looking at the time here, 4 minutes, 10 seconds. Let's look at another one real quick. Magnesium, for example. Magnesium wants to give away 2 electrons because it's in group 2A. It is an alkaline earth metal. So instead of drawing the dot diagram, I'm just going to show you that a magnesium ion, which has lost 2 electrons, is written as Mg, and up in the corner, instead of a plus symbol, it is 2 plus. Now, how could that bond with chlorine? Well, if chlorine can only gain 1 electron, you're going to need another chlorine atom to come in and grab another electron from magnesium, which wants to give away 2. Please keep in mind, this one is going to give away 2, but chlorine can only take 1. So what happens is another chlorine comes in, and the electrons, which I haven't drawn, email me if you need any help with this. It's in the book. I'm on page 172 and 173, if you're wondering. Chlorine, you need 2 of them to make sure that they each take an electron from magnesium, which wants to give away 2. The resulting chemical formula, I'm not going to erase it, will be MgCl with a subscript 2. So what you can do is you can take all of the elements in the periodic table of ions that I showed you, and you can basically make chemical formulas from the charges, making sure that they balance out. One more quick example, and I'll stop. I'm thinking. Lithium. You'll find that it has a charge on your periodic table of ions of a +1. It's in group 1A. It's going to want to give away 1 electron. Let's say it wanted to bond with oxygen. Lithium would give away an electron. It would have a charge. The lithium ion would have a charge of 1 plus. The oxide ion, we'll talk about the naming, has a charge of 2 minus. That's just the way that we write it. How can you make these two get together and have a charge of 0? How can you make these cancel out? Well, since this is only a 1 plus and this is a -2, you're going to need more of these. You're going to need 1 more of these to match the -2 of the oxygen ion, the oxide ion. We write it as lithium oxide, Li2O. Section 6.3 to follow.